Thanks, Nishi. Welcome, everyone. As she said, we're going to talk today about mobile applications and some proxy shenanigans. How's everyone doing today? Did you guys get out and participate in the shenanigans last night? I saw some of you. Just a real quick, how many of you were developers in the room? Pen testers? Something else? Anyway, so to jump right in, so we kind of probably all know why we're here. Mobile applications have exploded over the past few years. Right now, there's about 1.5 million applications on just Google and Apple app stores. That's a lot, and that has nothing to do with any of the internal applications that all of you are developing. So we focused this talk on just Android and iOS, specifically because we don't really see a whole lot of BlackBerry and Windows requests yet. I don't know if Windows is going to catch up to these two or not. Well, I guess we'll see over the next few months with some of the new releases. So obviously we know that these devices can do pretty much everything. I mean, I think back just a few years ago, '96, I think I had my first cell phone. It was about this big, looked like I was carrying a big 357 Magnum on my hip. And now I'm, hacking applications that run on these devices that do all of these things. I'm watching DirecTV and all kinds of stuff from my little mobile device. It's just crazy to think about all that. And this is why we're here. I mean, a real quick Google search, I think this took me about 30 seconds to come up with just a few mobile applications that have been found that have flaws and vulnerabilities over the past couple of years. And this is going to continue to increase. So obviously we need to employ our security practices that we currently employ in all of our web apps and our other client-server apps that we've been doing for years. For some reason, we're forgetting about it in the mobile space. We want to be first to market. We want to get there now, yesterday actually, and this is what happens. So why is the mobile space a little more risky? I think we all kind of understand that, we have these devices on us 24/7. Obviously, it's in my pocket. I go into Starbucks or Caribou or a coffee shop and I see people all the time. They got their computers, they got their mobile devices. They get up and go get another cup of coffee, run to the restroom, and leave their stuff. Well, we're fast. If I wanted to steal that, jailbreak it, install something, and return it to them, they probably wouldn't even know it. What does that mean for your applications? When you look at the applications from that standpoint. This is an interesting stat, right? So I just saw the other day that there are 6 billion cell phone subscriptions in the world today. Think about that. There's 7 billion people, right? That is a ton. I mean, not all of those subscriptions are for one person. I mean, I myself have 3, but still, that's an insane amount. Not all of them are going to be smartphones and run apps, but I guarantee you someday they will with some of the things Mozilla's doing with their new platform and stuff to target those smaller countries and so on. But 113 of these are lost every minute in the U.S. alone. That has nothing to do with the rest of the world. What does that mean to your application if someone steals a phone? Is there data on there that they can get at? It's things we need to think about. So these are the 3 types of mobile apps, real quick: client-server, mobile web apps. Some people might say that those two are kind of one and the same. I like to split them up because there's little differences here and there. But today's talk is really going to focus on the traffic. Most of the apps that we look at and do pen tests on utilize HTTP or HTTPS. And there's definitely issues when it comes to trying to proxy these apps. More so on the Android side, and Dan will get into that, than iOS, but there's also some things on iOS that we've seen recently that have caused issues. And we shouldn't be spending 2 days just to look at the traffic of an application. And that's not the point. The point is to secure the app. We should be able to do that quickly. So let's talk about that. If you've done any sort of pen testing or play with any of these apps, you've seen these screens quite frequently. Obviously, iOS on the left, Android on the right. So, proxying HTTP traffic in mobile apps is pretty straightforward, but not so when you get to SSL and TLS. In my mind, it's kind of like watching an elephant, right? I mean, you know what the end result is, but how you do it, I don't know how we got up there in the first place, but it's quite crazy. So I'm going to hand this over to Dan. He's going to dig into Android. Like I said, Android really is where we run into most of the issues when we're trying to proxy traffic. Android and Google have come a long way in the past year or so to help us in this respect. But anyway, Dan.
So there are two different issues that we run into when we start proxying the mobile apps on Android. And first of all is setting up the proxy, actually telling the device or telling the emulator that you want it to use your proxy. And then if the application is using SSL, there are some issues there as well. So first of all, in setting up the proxy, there are a lot of options to choose between if you try and search around. You can use the settings in the emulator are different from settings on if you're trying to test on a phone. It might be that you use a third-party app like Proxy Droid. If you're using the emulator, maybe you set the APN proxy setting. Maybe you give a command line argument to use an HTTP proxy. So there's a lot of things that you can do to try and tell it to use your proxy. And then the issue with SSL is that in native applications, they don't give you an alert that the certificate is not accepted, to say, yes, I want to trust it, as you would if you're testing a web application. And even in the Android browser, you can accept your proxy's certificate, but the native apps, oftentimes they just fail silently. It just doesn't work. So, with all of these options that you have to use, we've tested many of them, the different ways to set up the proxy, and they're kind of inconsistent. It depends on the environment that you're testing in. If you're testing in the emulator, you want to use one approach. If you're testing on a physical device, you want to use another approach. And they don't work for all applications necessarily. Some of the options may only proxy traffic for your for web applications, but it might get ignored completely for a native app, even if it's an HTTP protocol, which is it's a little frustrating. Doesn't seem like it should act that way, but it's what we've seen with our experience so far. So we've taken sort of an approach of the least invasive and most successful process to the most invasive and most time-consuming process to get a proxy to work. And ideally, it works, on the left side of this, and you don't have to go way down the rabbit hole with trying to set up a forward proxy for the application, because that can be rather hairy. So I'm going to talk about how we go about doing a reverse proxy, the most effective way that we've seen. So first of all, you're going to pick a proxy tool, Burp, Fiddler, WebScarab, Zap, whatever your preference is. And the next step is going to be to import a certificate onto the device if it's an application that uses SSL. And we would recommend that using ICS, I think is the latest version of Android in the emulator. It makes it a little easier for importing certificates. You can set up your proxy on a browser, get your SSL cert by exporting it, and then you just push it onto the device, and this will work with the emulator or on a physical device. And then on the device, under the settings, security, there's an option to install from SD card, and that just trusts your proxy certificate so that when you set up the proxy, it's not going to give you that error at all. And then to configure the proxy setting in an emulator is really easy. Under the settings, wireless networks, and down to access point names, you can set the proxy setting right there. But if you're testing from the emulator, there's a virtual network that it creates on your machine, right? So you have your host machine, and then you have the emulator inside of your host machine. If you tell it, like you would with a web application, that you want a proxy, the proxy address is 127.0.0.1, that's going to stay inside of the emulator, and it's never going to hit your proxy. So you have to use the Android emulator's destination for your host machine to get it to go to the right destination, to say 10.0.2.2. And these slides will be available. So once we put that in as the APN name, or proxy setting, and we start getting proxy traffic. So that's pretty painless and and we're pretty happy when it works that way. Sometimes you need to test an application from a device, though. It's not, for whatever reason, it's not possible for you to test it in an emulator. So if you're going to do that, if you root the device and install the certificate in the same process, you just need to install a third-party app like Proxy Droid or something along those lines. There are several, to tell the device to use your proxy, which would be some location on your network. Doesn't necessarily work for all applications. We've had some inconsistency with that as well. So it's, your mileage may vary, and you may have to take another approach. If you don't have ICS, it seems like you need to manually modify the trusted store. So that can be a pretty painful process if you have to go that route. It looks something like this. You have to pull the trusted store off the phone, which has to be rooted first, and then manually import your certificate, remount the file system, push the trusted store back on the phone. And it's a little bit of time consuming. So I would recommend, if possible, to use ICS when you're testing Android applications, just because it seems to be easier with that. But if none of those approaches work, we can try and set up a forward proxy, which, as I mentioned before, you can go way down the rabbit hole chasing this. So hopefully the reverse proxy is going to work for you. But so a forward proxy, you're going to tell the application to use your proxy as the server that it would be talking to. And then the proxy is going to send that traffic to the real server, without, the application doesn't care. It's, as far as it knows, it's talking to the real server. But in order to get that to work, you have to either modify and recompile the source code, or you're going to have to try and decompile, hack the APK file, which is also goes way down there. You want to get away from trying to manually edit the binary files if you can. It's not very consistent. If you ever tried to decompile and recompile a jar of a Java application, sometimes it works, sometimes it doesn't. So ideally, to do this, you would have source code, and you would just change the server name and the source code to the location of your proxy. So in this example, I'm telling it the proxy is 10.0.2.2, which is my host machine. And then the proxy needs to be able to support this forward proxy mode, and we've used Burp to do this. I'm sure that there are other ones that do. Same thing. So if you don't have this option, you can try and modify the binary by disassembling it. You got to locate wherever the URL is. It may be in a class file. It might be in a resource file. If it's in a resource file, it should be in pretty good shape getting the APK bundled back up. But if you need to reassemble class files, that can be very sketchy. But if you re-sign the application with your own self-signed certificate and put it back on your device or on your in the emulator, it's not gonna care as long as you've uninstalled the previous app. And this definitely does not always work. It's the last resort, I would say. So that looks something like this. I use an example of Facebook. I'm not going to go too deep into this, but I pulled Facebook off of a device and decompiled it. In this case, it did work, but I tried to do the same thing with a Twitter application, and I couldn't recompile it. So it's, if you have source code is the ideal way to do this, but it does work in some cases. But there are many tools and resources for modifying and hacking APK files. I've listed some of them here. You may have heard of APK Tool or Smalley. It's a very good Android APK decompiler. And then there are several places where people have done some research on that type of stuff as well. Ideally, reverse proxy will work for you. You want to avoid going down that route. So, and I'm going to hand it back to Dave to talk about the iOS proxying.
So iOS isn't as difficult, I guess, as Android is when it comes to proxying. It's just kind of always worked, pretty straightforward. But there's been some new things with iOS that we wanted to talk about. Obviously, trusting certs, that's the easy part. But what about this new found thing of cert pinning? The recent SSL issues on Android research that was just released a couple of days ago about some of this stuff and how more people should do cert pinning from devices. Well, what does that mean for testing? It makes it much more difficult, right? But we'll get into that too. So obviously you've seen these many times if you've done any sort of iOS testing from a device, from the simulator. I love the connection failure occurred. Well, what does that really mean? It doesn't tell you anything. And then cert pinning. I don't talk to strangers. So the new thing, like I said, is at least on mobile apps, is the mobile app won't talk to anyone but what it thinks the server is. And they do that by validating the server cert. So I'll kind of go into step by step too. Like I said, this isn't quite as interesting as the Android stuff and doesn't take as much time. But reverse proxy is real straightforward. Pick your proxy. It doesn't seem to matter which one you use in iOS. With Android, there's some other issues with some of the traffic, but I've used all of them. They all work fairly well. Step 2 is adding the CA to the device. There's many ways to do this. I myself like to use configuration profiles. They're much easier to add and remove with the iOS configuration tool. But as you can see, you can add just the cert itself and install it, remove it every time from your device. But I do this for many reasons. I install it and uninstall it to many, many different devices quite frequently. It just makes it a lot easier for me. And then step 3 is set up the proxy. Like I said before, most of you have done the testing before, have seen this screen. It's pretty straightforward. Obviously the device or simulator have to be on the same network as your proxy, and you set your proxy and port. And you should be good to go at this point, and we're happy, 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 as Phil would say from Duck Dynasty. But that's the easy one. What about the simulator? So the simulator is good and bad. So obviously most of you who know the Mac know that the Mac has a key store, keychain. Well, the simulator doesn't use it. It has its own keychain, and it has its own trust store. The reason they do this is because they want it to look and feel like the actual device itself. But it makes it a little bit more difficult to test. Early in iOS, there was a Python script release that would add your cert to the trust store, but that doesn't seem to work anymore. It only added the SHA-1 hash of the cert, but you need a little bit more. So the only way that I've been doing it is I just grab this file off of a device once I've added my cert to a device. And then I can just put this trust store SQLite 3 file onto my Mac, and it will just work then in my simulator. Seems to work pretty straightforward. Other than that, I'm sure we could look into updating the Python script, but most people who are doing some sort of testing would have access to a device too. And then you always have it as long as you don't change machines or update your proxy. And then it does utilize the system proxy. So it doesn't utilize the keychain, doesn't utilize any of that, but it does use the system proxy on your Mac. So you got to go in and you set up your proxies here in the Mac, and then it should work. Sometimes it doesn't seem to pick that up right away, and you got to stop and start Xcode and all that a few times, but it will eventually work, and then your cert should be trusted. And then it's on like Donkey Kong, right? We're good to go. Like I said before, I don't want to spend 2 days trying to set up proxy. That should be something that's quick. There should be a document that walks me through exactly what to do. And there's thousands of them on the web, but some of them work, some of them don't. So cert pinning. Like I said, we've been seeing more of this. Twitter does it. Some of those social networks and so on are doing more of this, where they say, I'm not going to talk to anyone but who I think the server is. And that does cause issues when we're testing. Some of our clients are very sensitive and they want to do cert pinning, but they still want us to test. So how do we fix that? Well, it doesn't have anything to do with Pinterest. But this little tool here, it was released at Black Hat by ISEC partners called SSL Kill Switch. It is awesome. Basically works on a jailbroken device. It's a mobile substrate extension that disables cert validation and NSURL connection. And it works really, really well. So well, in fact, that it scares me a little bit that an attacker would install it on your device and hook you up to their proxy, and now they've pretty much compromised all of your traffic. But it's really, really good.
So does that mean, like, if you have a client server app, like, let's say, the Time Warner app that installs on iPads, and it actually checks its SSL certificates?
Yeah, it shuts it off, you know, because those are all using NSURL connection, at least at the
So
low end.
it's not just for like the
No.
web browser.
It's for the entire device. It shuts it off, yeah.
Is there an Android version of that?
So at Black Hat, they talked about an Android version of this. It was supposed to be released 2 weeks after Black Hat. I haven't seen it yet, and I haven't talked to them, so I don't know if it's something that they're coming out with or running into problems. It didn't seem to be as straightforward as this. I mean, this is an easy install. I mean, it installs in less than a minute. You know, it's on Cydia, so it's great. So this is what Twitter looks like before it, right? So like I said, Twitter is doing cert pinning. This is my iPad. I get this weird error that doesn't really tell me anything. It says I can't connect. So I install SSL kill switch. Voila, look, I've got traffic and I've got Twitter working. It just shuts it off, the cert validation. Like I said, it's good and bad. It helps me when I want to test, but it also helps the attackers. And it's scientific, right? So, so summing it all up, it's interesting, right? So when we submitted this talk a few months ago, it was even more difficult on the Android side. ICS hadn't come out really yet. The cert upload and trusting thing didn't even function. I mean, most of this talk was really focused on Android, because iOS has always just kind of worked. But we always had issues with Android. It never seemed to work the same with different apps. And we still run into those issues. But I think, you know, step one here, determine which method works for you or your app and stick with it. Obviously, we want to do a reverse proxy as much as we can, but sometimes that's just not going to work. And know any SSL gotchas of whatever OS you may be testing, whether it's Android, iOS, or whatever else. Now, here's where we come in, and OWASP should come in. The only difference between screwing around and science is writing it down. Like I said, there's thousands of these guides of how to do this out there. Some of them work, some of them don't. What we want to see is we want to see this as part of the mobile project, and I'll talk to Jack about this, is providing these guides so we don't have to waste days at a time trying to set up proxies, because that's not the point. The point is to test the apps and make sure that they're secure as can be. Right now, we have internal guides that we're going to donate to at least get the ball rolling, and then anything else anyone else has seen, we can add and modify at that point. Obviously, this is focused strictly on HTTP and HTTPS. If there's apps using other protocols, there's Mallory and other things too. But for the most part, I think I've seen one app that uses UDP, and everything else is some sort of web service or using backend HTTP or HTTPS. And that's it. This is available for download. Yeah, you're fine. Right. It's available for download here. I believe it's going to be on OWASP site too. Yeah, questions?
When are you going to post your GDP?
Hopefully within a couple weeks. We just got to organize what we have because it's kind of all over the place. And then hopefully we can get the community to add the things they know and do and so on.
You said Android stuff's been getting better over the last couple of years. Any feeling for whether Jelly Bean is delivering funnels going forward or makes it easier, or just new problems?
Well, I mean, we were having this discussion the other day, and you can talk to some of it as well. But there are some security stuff that is suspected that they're implementing that we know that they're going to implement. Like I think the next version of Android is going to get SE Linux, and what was
multiple user profiles on device.
That's the next one. What about Jelly Bean? You guys got any career in that?
I'm not positive what the differences would be off the top of my head.
Anyone else?
So what makes the difference? You said some of the applications all this, others don't. What's the difference as far as
Specifically, so we have with the reverse proxying of the native applications. If you use one of the examples I gave was using a third-party proxy tool to if you're testing from device, and for whatever reason it only works with certain applications. There's random times we can't get it to can't get it to work. There are instances with cert ping where we can't do reverse proxy, and we have to do forward proxy. So that's another example. Because you can forward proxy over HTTP. You can tell it use my proxy without SSL, and then if the real server is enforcing SSL, you can tell your proxy to do SSL on the back end, and the app is
Yeah, I mean,
that's another
as an example, one app we tested was doing some cert validation. It's from VeriSign. I mean, it wasn't really doing cert pinning, but it said make sure it's from VeriSign. So we tried the forward proxy and it just bypassed that piece in the code. So now it's not verifying because it's not SSL anymore. So that's really the use case for that sort of thing for forward proxy. Can't think of any other.
Yeah,
I mean,
the main thing is just the difference in what approach you need to use depending on the environment and then depending on the type of application. If it's a web app, you can use option A or B, but if it's a native app, you need to use C or D, and that can be kind of confusing unless you have gone through the motions of the 4-day process of trying to learn and figure out what approach do I need to take, and I think that's one of the reasons why we need to have a good guide that's updated, because this information may change and some of it may not even be correct, right? Like we've done our best to document the issues that we've had, what works in what environments, and the chart that I threw up there for 5 seconds, but it's probably not all inclusive, and probably there are issues we haven't thought of. So.
Have you guys seen any differences in the behavior of proxy tools depending on whether the device is permanently rooted or temporarily rooted? Because there's tools where you can temporarily root your device versus permanently rooted.
Yeah, I don't think that impacts proxying. Some of the proxies don't work with the reverse proxy option. There's some. I think the Android emulator sends a HTTP. Like
it says a SSL connect,
yeah,
right?
SSL
And,
connect
and a lot of the proxies will just drop it.
Yeah.
And it gets confused, right?
So, and then the only option is to use a forward proxy.
Yeah, it's trying to connect to the actual IP address, which confuses it. But Burp, for instance, has fixed that on the proxy side. So Burp, the newest version of Burp Pro works with Android now, but some of the older proxies don't.
Some of the few apps I've tested, I found proxy try to be more stable than, let's say, root proxy. For example, root proxies can be.
Yeah, I've really grown accustomed to that tool. I was using ASP proxy for a while, but that's, you gotta pay for it.
To give you an example, like when I do Android testing, I don't have a permanent root on the device that I use. I usually test from the emulator, but if I need to test from the device, I don't have a permanent root. I usually use PS neuter, which is a reboot, and then it's back to normal, and that hasn't impacted me yet.
So the Z4 root works.
Yeah,
Yeah.
Z4 root works well too.
Yeah.
Yeah.
Can you speak to a little bit about doing the web services and what Proxy recommend?
I mean, from my standpoint, I use Burp. I know Dan and others like the Zap proxy, but they all work just fine for any sort of web service testing that you'd be doing. It depends on how many custom requests you want to create and how you want to do that. Some of them work better than others, but I'm pretty much a Burp guy just because of the Android thing too, with the way it does the connects. But
Or SOAP UI, right?
yeah, SOAP UI works pretty well too as far as sending direct web service requests. If you're talking SOAP or anything else?
Do you have a question?
Well, thanks. Appreciate it.